Welcome back to my next video. Earlier we have discussed about density and converting the unit. So those are few examples of density of a different substance such as air, ethanol, water, mercury. So actually we can use those values to calculate the mass or volume of a different mass. So we proceed further. Yes, converting unit. Converting unit is the most important substance over here. Let's put it over here. Okay, remember, normally temperature, the scale will be in Kelvin. We will measure it in Kelvin. So how to convert? Let's say you have a 25 degrees Celsius. You want to convert it to Kelvin. Very easy. You just need to plus with the ambient temperature, absolute temperature, which is whatever measurement that you have from the thermometer, you plus with the 273.15, then you will manage to convert it to the Kelvin. And over here, as you can see, other than Kelvin, we also can have a Fahrenheit, degree Fahrenheit, this one, degree Fahrenheit. How to convert it is actually 9/2 multiply with the temperature that we measure from the thermometer, then we plus with 32. That is how we change the temperature from degree Celsius into Kelvin, or either degree Celsius to degree Fahrenheit. So as we can see over here, more examples. Actually, yes, we have to convert this one, to convert a degree Fahrenheit into a degree Celsius. How to change it? Very easy. You have a Fahrenheit, the value is given over here. You just substitute into the formula and you rearrange, you bring this to the other side and it become minus, and this is multiply when you come over here it become divide, and you exchange the position and you get this, and finally you have a degree Fahrenheit, which is you can get it from here. You substitute over here. Once you have substituted over here, then you manage to convert it to degree Celsius. This is how you do the interchanges. Chemistry in actions, more examples. So you can read this. This is not much. Oh, this is what we have I have mentioned in a previous slide, a scientific notation. Why there is a scientific notation? We don't want the number to be too huge. This is waste of time to write it down. Each time we want to write it down such a big number, this is waste of time. Therefore we change this value into a scientific notation, as you can see over here. Normally you must remember, this is what we call it the power. It could be a positive value or negative value. If it is a positive value, the number is bigger than it's a positive value, bigger than 1, more than 0. And if you get a negative value like here, that's indicate the value is less than 1. So the number at here in front over here is actually a number between 1 to 10, and here, as I told you, it could be either a positive value or a negative integer. A positive value stands for bigger than 1 and bigger than 10 actually, and when you have a negative integer, that stands for less than 0. Okay, then you can have a look over here. There are few ways to convert the scientific notation. As you can see, if let's say we take this number, this is your decimal point, look at here, I want to change it to a number that is less than 10 but bigger than 1. So I move this to left hand side twice. Then I will end up getting 5.68762. Since I have moved this decimal twice to the left hand side, therefore it is a positive integer. It's going to have a positive value, power of 2. If I move it to the right hand side, that indicate the value is less than 0. Over here, this is the decimal point, and I move 1 2 3 4 5 6 times in order to make the value that I get, the final value that I get, is less than 10 and more than 1. Since I have moved 6 times to right hand side, therefore it is a negative integer, negative number. So addition or subtractions of this, let's say you are given a number like this and another number like this, you want to plus them together, it is most advised you make the integer to be in the same order before you do the calculation. So since over here is power 3, I want to make it as a power 4, then I will move this integer to left hand side to make it 4, then I can easily plus the value, and this is my final answer. And more calculations, multiplications also like this, you can have a look. I'm sure you will come across this kind of calculation a lot later in your chemistry field. So you have more and more calculations. Significance number, let's have a look. Okay, significance number is very important rules that we need to apply in most of our chemistry calculations in order to standardize the calculation for the calculation purpose. So as you can see over here, the first things, you are given a number like this, we are going to look the significance number. So remember, the first rules of a significance number, any digit that is not 0 is significant. So over here, as you can see, you have 1 2 3 4. How many numbers? 4. Therefore we call it as a 4 significance figure. Please remember, this significant number play an important roles, particularly in the calculations of the mole and molar that you will calculate later. And also the second rule, 0. If there is a 0 at the middle of any number, we still count it as a significance number, such as over here 606. So the 0 at the middle, we count this as 3 significance number. But nevertheless, any zeros to the left of the first non-zero digit is not significant. Stand for over here, the 0 that is in front of here is not counted as significance. Therefore this one only have one significance number. And if a number is greater than 1, and then all zeros to the right of the decimal, this one, as you can see, so look at it, the way that we put it over here. So here 2, then there is a number at behind after decimal, we still call this as 2 significant. And finally we do have this over here. As I told you, these rules are almost similar with over here. As you can see over here, the 0 at in front is not counted, but the 0 at behind is counted. So the how many significant numbers over here is called as 3 significance number. So a simple by quick recall, this one we have a 2 significance number, 4 significance number, 3 significance number, Over here they put it in a scientific notations. How many number we can see? 2, therefore 2 significance number, and this one only 2 significance number. The 10 at behind is not really counted. Okay, so we have done with this. Some calculation, mathematic operations. If we are taking a simple like this, 1 significance after decimal, or you are calculating this, so if you involve a plus, addition, or subtractions, minus, remember the final answer will take the smallest value over here. Stand for, look at that. Here I have 1 2 3 4 5 significance. Over here I have 2 significant number. Okay, so your final answer, how to report a final answer? So you look at the decimal point. So over here, which one have the smallest number of decimal? Here I have 1 significance figure after decimal point, so we take the final answer, not like this, we report according like this, 90.4. The same go to here. Here I have 2 decimal point, here 4 decimal point. Your final answer should be reported as a 2 decimal point. We take the smallest one, so this is your final answer. So that's it, done with the significance number. Let's proceed a few more slides. When it involves multiplication or divisions, this will be a different story. As you can see, we will take the smallest number of significance number. Earlier, we are consider plus and minus, we are considering the decimal point. For this case, we are considering the significance number by taking the smallest significance number. What do I mean by over here? This is multiplication. Here we have 3 significance number, and here I have 5 significance number. So our final answer should be reported as 3 significance number. That's why we get this. Go to here, multiplication, division 2 significance number, and I have 5 significance number. The smallest is 2, then I will report my final answer according to 2 significance number. Done with it. So we have this one, accuracy and precision. Accuracy is how close a measurement. In chemistry you will come across of those terms, is when we are talking about accuracy, how close a measurement is to the true value, and precision is how close a set of measurement are to each other. It is not necessary to be close to the true value, such as like this. I will say this one 100 is your true value, and we notice the shoots over here, the points are very close to each other to the true value, so I can label this as very accurate and a very precise one. Over here, those shootings, those points are very far away from the true value, so it is less accurate. But the one over here are accumulated in a one same place, therefore we call it is very precise but not accurate. If the third example, they are sketched random, they are very random all around the place, so I can say they are not accurate and not precise. So few examples, analysis method.